building was built brand new, which means
In the event of transformer failure, it's actually just the cover, this is really a tin shroud that comes off.
Yeah.
The core coil in there,
Yeah.
you can load that up, it will come up.
yeah. So the doors and the hallways in this building are built big enough. When you're building the building initially, you're coordinating with the architectural guys saying we have a 8x8 transformer that's going to go into this room. We need a way to get it into the room if you're not going to provide a lift out well. And we need a way to get it out of the room once the ceiling is on, and the doors, the hallways, and the ways of getting in and out of the building are sized big enough to get the electrical equipment out. In Schulich, because it's existing, you can't do that. You can't just say, well, we need a hallway to size or to be able to pull a 10x10 transformer through, because the hallways are already there. So you build what is essentially, it's not an exterior transformer room, but the transformer room in Schulich sits proud of the building out in the loading dock area. That being said, you're not going to be digging up asphalt, so to put some sort of lift out well in is very common. It's extremely common in downtown buildings when you're dealing with NMAX. If you're walking down the street and you see all those grates, sometimes you'll see a little footprint that says electrical. That's a lift out well. They basically pull it out and can drop transformers into the building or the sub-basement, lower basement levels of wherever they're putting the electrical gear. That's basically the...
Yeah, one thing else I want to mention is we have been specifying TVSS, surge suppression, as close to the main incomings as possible, and I think you all have also started to put it on some motor control centers. Typically we never did this before, but with a lot more electronic equipment, electronic research equipment, we are trying to clamp any sort of surge or transit that does come into the building right at this board level. Stephen mentioned about the main tie main. In these facilities, we can actually isolate a transformer, energize, so you do not see a power outage in the building when we are doing that. We do that by making sure the transformers are the same size, the same impedance, fed off of the same front end gear, and then we are phasing the three phases coming into the tie breaker the exact same. You don't want to have it that you feed one board and your phasing is different. All of your motors on that side would turn backwards or anti-clockwise or clockwise. So we'll do this in part of our commissioning, making sure that all the phasing is done. We're making sure all the phasing on the high voltage side is done when we're bringing it on. So a lot of the engineering will come into the commissioning stage when you're starting up the equipment, and that's where we work with Scott and Stephen to make sure that it's put in as per spec, it's tested, all of these protection relays, the coordination study is handed over to a group that will come in here and dial in the setting. They will put their secondary injectors on the CTs, they will inject the current and see that the breaker trips at the setting that the coordination study shows, and then once we get that commissioning report, our group will start to energize the facility. So there's quite a process to it from day of inception to the day you turn it on.
Yeah, there's, just to give an idea with Schulich, eeel was done the same way. So the Schulich building, in terms of the high voltage gear, we have been designing, discussing, refining, ordering, procuring, changing, all of that stuff for high voltage gear to go into the new Schulich facility since 2010.
Yep.
Since 2010, and the gear is only starting to arrive on site. There's some delays in there and whatever else, but it's not a, and Scott can attest, the equipment in this type of room, panel boards, I mean, you start to get your lead times a bit smaller, but this type of gear is not just gone out and bought from Home Depot. It's not gone out and bought right off the shelf from Schneider. This is custom to a point, but custom designed, not off the shelf gear. It takes a long time to replace. So a lot of people, when we're going through design phase, say, why do you have two transformers in here that are the exact same size when one can run the building? Why do you have that redundancy? If you lose, the downtime at the university is far more costly than the cost of an extra transformer and an extra main tie main board. If you lose a transformer in this building, you do not just go out and buy a new one and have it here over the weekend and the building is up and running again. These are 12, 16, 18-week delivery to get a transformer like this to be replaced. So more and more we're seeing in the new buildings of the university this type of redundant system put in, where you've got essentially a double-sized system where you minimize your downtime. Now I don't know the last time, Raymond can attest, of when we've actually had a facility go down for a long duration of time because of a power outage. Ideally, if you lost a transformer in this room, your occupants would probably never really know it.
Yeah, we probably have a 2-hour shutdown in this, just by the time we got in here. Isolated the problem, found out what the problem is, isolated the problem, and transferred it over. We have had a transformer failure at the Olympic Volunteer Center in the beginning of spring. That was a MX pad mount transformer outside, 750 kVA transformer. It was a 36-week delivery, so we had to run that building on a generator for a week and a half, and on Sunday, we're putting the new transformer in. We had to borrow a transformer off of an MX to get us going over the summer, and it's taken 36 weeks before we got a transformer delivered to site here. In boom times, in Alberta, it even gets longer.
During the flood, getting electrical equipment in this city was next to impossible. Better yet, getting electrical equipment outside of the city was next to impossible because of the amount of gear that was being replaced in and around the city. High voltage gear, 600 volt gear, transformers, you know, it's tough to explain it to people that don't really understand what it takes to get this gear, because it just looks like a bunch of nice boxes with